Welcome to the presentation based on the research called The Risks of Loss of Personal Data in the Process of Sending and Printing Documents, prepared by Oleksandr Tymchenko, Bogdana Gavrish, Orest Hamula, Serhiy Lysenko, Oleksandr Tymchenko, Katarina Gavrish. The contents are as follows: Introduction, General Analysis of GDPR, Designing Systems According to Requirements, Characteristics of Personal Data Protection, Network Printing, Results of Experimental Studies, and Conclusion. The recently implemented General Data Protection Regulation is forcing many companies to make significant changes to their systems to meet new requirements. As Ukraine has an association agreement with the European Union since 2014, Ukrainian printing companies must be ready for such changes to be able to cooperate with European companies or provide services to foreign customers. This regulation also applies to the export of personal data outside the European Union and the European Economic Area within the framework of European Union legislation on the protection of personal data of all users within the European Union and the European Economic Area. The introduction of new functionality which must be performed in real time reduces the bandwidth of systems by 20 times. New technical challenges are emerging that need to be addressed to effectively achieve strict compliance with GDPR. Therefore, to comply with the GDPR, it is necessary to make changes in the data processing and storage systems. The paper analyzes the problems of retrofitting existing systems following the law, changing the methods of using storage systems by the GDPR standards, in particular the risks of loss of personal data in the process of printing and transfer of documents for printing, the passage of the document through various stages from launch to the final product, the individual stages, existing risks, and weaknesses of the security process are illustrated. The General Data Protection Regulation is set out in 99 articles describing its legal requirements and 173 summaries that provide additional context and explanation to these articles. The GDPR is a set of regulations covering the entire life cycle of personal data. Thus, achieving compliance requires interoperability with infrastructure components as well as operational components. For analysis, it is necessary to use articles describing the behavior of storage systems. They fall into two broad categories: the rights of data subjects and the responsibilities of data controllers. Based on the analysis of GDPR articles, it is possible to identify 6 key features that a storage system must support in order to be compatible with GDPR, and also to characterize deviations of systems in support of the basic functions necessary for the performance of regulations. This slide shows storage characteristics according to the GDPR standard: timely removal, monitoring and logging, indexing with metadata, access control, encryption, and data location management. Real-time compliance is when the system completes a GDPR task, for example, deletes expired data or responds to user requests synchronously in real time. Given the harsh sanctions for violating the law, it would be advisable for companies to delete the data as soon as possible. However, to meet the requirements of the law in real time leads to overhead costs. This problem is exacerbated by large organizations. Systems that differ in response time demonstrate different levels of detail and capability. These differences are due to the fact that many requirements of the GDPR depend on the design principles and performance guarantees of certain systems. For example, file systems do not implement indexing to files as a basic operation because this feature is usually supported by applications such as grep. Thus, we define full compliance in order to support all GDPR functions and partial compliance as supporting functions in combination with external infrastructures or components. One of the elements of personal data protection is the optimization of the complete printing process, as it often goes unnoticed that there are significant security risks in the printing process. These include not encrypted transfer of personal data over the network, not encrypted storage of personal data during the printing process on servers or printer hard drives, output of confidential documents to incorrect, unprotected printers, documents containing personal data that are received by third parties from the printer. The probability of losing personal data during printing will be the sum of the corresponding probabilities. The first diagram shows the printing process from the application through the print server to a network printer. The second diagram shows the encrypting process of print data at all stages of the program through the print server to the network printer. You can use a print server to centralize printing processes and reduce the risk of losing personal data. This not only simplifies administration, but also makes it possible to implement security technologies, as it allows to protect data with encryption using application software. In this case, the attacker needs to access a secure print server, which makes it virtually impossible to lose data or reduces it hundreds of times. Administrators protect programs and data through access protection and encrypted connections to servers and workstations. On the other hand, print data is often sent unsecured to print servers and from there to network printers. This leads to the following weaknesses. Network cards of all devices covered by the print stream. Workstation, desktop, a network switch, router, server, a network printer. Printers share access to the print server. Access to network printer hard drives. From the server message block, the print data must be encrypted by a printer sharing program on a print server with Windows file sharing capabilities. This allows interoperability and access to shared printers on the print server only through encrypted connections, which reduces the likelihood of losing unencrypted data. Only third-party solutions can be used to connect from the print server to network printers. The decisions of individual printer manufacturers increase the administrative burden because they must be installed and managed for each printer user on the print server and errors due to the output of data to other printers. So there is a need for a universal manufacturer-independent solution that is also compatible with a large number of different structures and libraries. On the network printer itself, the risk of data loss by third parties is quite high, so we need to make sure that unauthorized person cannot enter the printer interface. To do this, we use certificates that require a username and password. If you are using the printer's internal hard drive, it must be encrypted on the hardware side. The table shows the average values of information risks, which should be used to calculate the probability of data loss. As we can see on this slide, the failures of technical means have the highest average rating. After analyzing the impact of articles requirements of the GDPR on data storage, processing, and transmission systems, we can conclude that achieving strict compliance with the requirements is a difficult task. Attempting to strictly comply with all regulatory requirements leads to a significant slowdown in systems. Therefore, to better study this issue, it is necessary to conduct a detailed analysis of existing data storage systems and analyze them according to the following parameters: efficient logging, deleting, indexing metadata. As shown, the printing process, which is an important element of the system of storage, processing, and transmission of data, goes through various stages from launch to receipt of the final product. A network printer also poses a security risk. When printing to a network printer, it is not guaranteed that users' data will not be disclosed to third parties. The paper proposes a reasonable scheme of the process of encrypting print data at all stages from the program through the print server to a network printer, which minimizes losses and security of the data processing process. Thank you for your attention.